Okay, here we go. We start radicals today. So this is the packet for simplifying and manipulating radicals, day 1. And this is a warm-up. So prime factor the following numbers. So stop the video right here and work on these 3 problems. You know how to prime factor, right? When you are done with the 3, come back here. Okay, and you finished 3, so let's check. This is, a lot of people do this, I've seen. So you do 2 and 64, and then you do 2 and 32, and then you circle the prime factors. I think that's how you learned in middle school. I want to show you the way I do it, because I find that that's less mistake. I've seen a lot of people doing that 3 things and end up getting very confused which are the factors and then run out of space and you get it wrong. So this is how we do it in Japan. This is how I learned it. Okay, so you put like this. Okay, and then, okay, I see 2 in here, so I do 64. And I see 2 again, so it's 32. And I see another 2 and 16, 2 and 8, 2 and 4, and 2 and 2. And this way, it's very contained. It doesn't keep going to the different parts in the tree. And also the prime factors staying outside of the bracket. Okay, so until you see only primes on the outside of the bracket, you keep doing it. Okay, so that means 1, 2, 3, 4, 5, 6, 7. So 128 is 2 to the 7th. Okay, that means 2 times 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 2. Okay, so that's prime factor. Okay, this one, let's do the same thing. What can we divide this by? 3, right? So you divide it by 3, and you got 4. It's like long division, so you have 3 times 4 is 12. I'm sorry, you divide 3 into this, and then you have 4 and then 2 left, so that's 27. That's 9. Okay, now you see 7 and 7. So you have 3 and 7 and 7. So 147 is 3 times 7 to the 2nd. Okay, 72. 2, 36, 2, 18, 3 and 6, and 3 and 2. It's all prime. So you have 3 2's, 2 to the 3rd times 3 to the 2nd. Did you get the same? Okay, let's move on to the page 2. Okay, so here is the basic idea. Oh, by the way, you need to be able to do this to do the simplifying radicals. You need to understand what prime factors are in each numbers to be able to do the simplifying and the manipulating radicals. That's why we did this practice. Okay, all right, so I'm going to go through this explaining to you line by line, and then we do some problems. Okay, so radicals are not so radical. It's not that difficult. Okay, so just keep your mind focused, and you'll get this. So you know that 3 squared is 9, right? The square root reverses the square. So the square root of 9 is 3. Just like subtraction reverses addition and division reverses multiplication, right? So 2 plus 3 is 6, and 6 minus 3 is 2. That reverses, the plus and minus reverses. And 2 times 3 is 6, and 6 divided by 3 is 2. So those are the reversing operations. And the square and radicals are the same thing. Okay, so the square root of 3 means that when you square this number, you get what you have inside the radical. So square root of 3 to the 2nd, which is, this is square root of 3 times square root of 3. that will make a 3. Okay, another way to look at this is this one. You can combine two square roots that are multiplied into one square root. So square root of 3 times square root of 3 in two different roofs here. You can make it under one roof, and 3 times 3. So that is a square root of 9, which is 3. Square root of 9 is 3. Okay, you can also combine two square roots that are dividing into one square root. So the square root of 32 over square root of 2 in two roofs, you can make them into one roof of 32 over 2. That means you can divide this. You can simplify this fraction, and that's a 16. So that's square root of 16, which is 4 times 4. So there are two square root of 4s. That means it's a 4. Okay, the square root of 32 over square root of 2 is 4. Okay, because you can combine two square roots that are multiplying into one radical, square root of 2 times square root of 3 is square root of 2 times 3 in one roof. So that means it's a square root of 6. Okay, so you can multiply inside the radicals into one radicals, just like here. Square root of 3 times square root of 3 is square root of 9, and so forth. Okay, all right, page 3. You divide the whole number into the whole number and square root into square root, but don't mix them. So you can do this. Square root of 6 times square root of 5 over 3 is the same as 6 over 3 times square root of 5, right? Multiplying, bring this number over to the numerator. So these two are the same thing. You can simplify this part too, and that's a square root of 5. So if you see this, you can divide the whole number into whole number. But this does not divide into this. Okay? You don't distribute. If there is a plus in here, you can distribute. You have to distribute. But there is no plus, it's a multiplying, it's one term. So you can only divide into the whole number. And here again, if there is a radical, this cannot divide into 6. Because radical and the whole number you cannot divide. But radical, square root, and the square root you can divide, right? We did this over here in the page before. You could divide 2 into 32, right? So it's the same thing here. The 3 into 12. So this is 6 times square root of 12 over 3, which is 6 times square root of 4, which is 6 times square root of 2 times 2, which is, that's a 2, right? The 2 square root of 2 become a 2, so that's 6 times 2 is 12. Okay. These two things are completely different things, okay? Because there's no radical here. Square root of 12 over square root of 12 and square root of 3 is the same as square root of 12 over 3. These are the same, but you can see these two are not the same, right? So the whole number 3 in the denominator never divide into the radical in the numerator. Okay, also remember that 2 root 3 over 3 is 2 over 3 times root 3. And it is not 2 over 3 times square root of 3 over 3. This happens all the time, this mistake. Somehow you feel like you have to divide into both. And since you can divide the 3 into radical 3, you leave it like square root of 3 over 3. No, you can't do that. This is one term. I think I have it somewhere here, but I'm going to explain here as well. If it's 2 plus square root of 3 over 3, then yes, you have to distribute it, because this is the same as 2 over 3 plus square root of 3 over 3, right? This and this, not the same thing. Not the same thing, okay? Next, when radicals are multiplied, you can change the order, just like you can do 2 times 3 is 3 times 2. When it's multiplied, not when it's divided, right? When it's multiplied, you can change the order. So 3 times 2 root 3, I mean square root of 3 times 2 root 3 is the same as 2 times root 3 times root 3. This becomes a 3, so 2 times 3 is 6. All right. Find your final answer cannot have radicals in the denominator. You need to rationalize it. Okay, final answer though, only final answer. You can have radicals in the denominator in the process of calculation. If that's the final answer, you have to rationalize it, okay? And this is what you do for rationalizing. You can divide the radicals in the numerator. You can have the radicals in the numerator. Okay, the radicals in the numerators are okay, but not in the denominator. So you have 2 over root 2. There is a radicals in denominator. We have to get rid of this. Okay, so what you do 2 over square root of 2 times square root of 2 over square root of 2. Because this is a 1, right? That's a 1. And you can multiply any number by 1, and it's the same number, right? So you can multiply by the denominator over denominator. Now, this means square root of 2 times square root of 2 and 2 times square root of 2, right? This right here. So the denominator become a 2, numerator is 2 root 2. Now you can cancel 2 because those are whole numbers, and what's left is square root of 2. Okay? All right. Page 4. Okay. Your final answer have to be simplified. Okay. So, for example, you have square root of 64. You see that that's 8 times 8. So you can't leave it like that. You cannot have two factors, the two same factors in the number inside the radicals. So 8, this is 8, have to come out. The same thing, the 8 is 4 times 2. And 4 is 2 times 2. So this is the same as square root of 2 times square root of 2 times square root of 2. So this become a 2 because you have 2 of them, and there's 1 left. So this is 2 root 2. So you can't leave radical 8 as an answer. You have to get this 4, make it a whole number, and take it out. Okay, same thing here. 200, square root of 200 is 100 times 2. 100 is 10 times 10. So this have to come out and become 10 root 2. Okay. And finally, don't get confused with this. This happens all the time. They're very similar to what we just talked about over here, right? Don't distribute the 3 here because there is no plus or minus, right? You can this is 1 term. These are 2 terms. Over here, the same thing. This is 1 term. Right here, this is 1 term. These are 2 terms. If it's added or subtracted, those are 2 terms. If it's multiplied or divided, that's just 1 term. Okay, so this one is the same as square root of 3 times 2 times square root of 3. Right? So you can change the order. So 2 times square root of 3 times square root of 3. This becomes 3. So that's a 6. This one you have to distribute because that's 2 terms. So, yeah, so right here, this is 6. We just did that. Now let's look at this distribution. 2 times square root of 2, so that's the first part. And square root of 3 times square root of 3, that's the second part. The first part stays as 2 root 3. The second part becomes 3. But this is not 5 root 3. This is the final answer. You cannot make it any simpler than this because you cannot add 2 root 3 to 3. The easiest way to think about this is replace square root of 3 with x because your brain is used to thinking it that way. So let's just assume x equals square root of 3, right, in this case. So you can replace this with x. 2x plus 3. That's not 5x, right? That's not 5x. You know that. You leave this as an answer. Same thing here. When you get confused, replace the radicals with x and see what you will do. Okay? Lastly, you can only add and subtract radicals with same numbers inside the radical. So 2 root 3 plus 5 root 3 is 7 root 3 because inside the radicals are both 3. Then you can add 2 and 5. But look here, it's a 3 and 5, right? You can add them, but so many people do this. So 2 and 3 and then 5 and 3 and 5 and 8. No, you cannot do this. This stays there. And the same thing in this kind of situation, just to replace with x and y. So x is, if you are confused, x equal root 3 and y equal root 5. So replace that into here. It's 2x plus 3y, right? You cannot do anything with this, right? This is not 6xy or 6x plus y, right? So this is where it stays. Okay? All right. Page 5. Simplifying radical rules. Rule number 1. No radicals have perfect square factors other than 1. So this is this one right here. Like these. You cannot have perfect squares. Perfect squares are 2 factors multiplied twice. Okay, so 64 is perfect square of 8. 100 is perfect square of 10 and so forth. So you cannot have a perfect square inside the radicals. No radicals contain fractions. You have to simplify fractions and get rid of it. And no radicals appear in the denominator of a fraction. Okay, so that's the rationalizing. Okay, so I want you to try all these as a homework. Okay, and we review these in the class. Let's try here together. Okay, so you see x squared, so you know the x is going to come out, right? Because there are 2 of these. Because this means 75 times x, right? 2 perfect squares that will come out. So that's x square root of 75. Now 75, if you prime factor, you get 5. And there's 1 5 in 7 and 25, that's 5. That's 15, so another 5 and 3. So it's 25 times 3. So 5 will come out because this is x times 5 times 5 times 3, right? These are the prime factors in 75. So 5 will come out. So you get 5x square root of 3. Okay, that's the answer. Okay. I want you to try these. And let's do this one. Okay, so these are homework. You know what? I scratched this. You don't have to do this as a homework, okay? This video is long enough at this point. So we do these in the class. If you want to, do these, but these are not homework, okay? I'm gonna give you one problem in the survey later to do as a homework. But today your job is to understand this video. All right, so let's try this one. Let's look at these first. Okay, so there are 3 x's. So one x is gonna come out. And just we leave the 72 in there. 1x stays, right? Because 1, 2, 3, 2 is going to make it 1 outside. 1 stays. There are 4 of y's. So, actually, I didn't make enough space. Sorry. So y is going to be squared because there are 4 of them, right? You need 2 inside to become 1 outside. So there are 4 of them. so it comes out, and 2. And there are 5, so then it's a z square, and then one of the z stays. So what's inside is 72 x, there's no more y, and 1z, 1x and 1z. Now let's look 72. This is y. All right, so 72, it's prime factor 72, 2, 36, 2, 18, 3, 6, 3, and 2. So 2 is going to come out, and 3 is going to come out, and 2 is left inside. So this is x, y square, z square. 1, 2 is going to come out, 1, 3 is going to come out, and what's left is 2 and x and z. So now this is 6, right? So, sorry, this was out of the place. All right, so then you get the 6x y square z square square root over 2x z, and that's the final answer for this one. Okay, we do these in the class. Let's look in the back. All right, so let's just simplify. We do this in the class. Which one should we do? Okay, so let's look at this one. All right, so you got 25. Square root of 25 is, what is it? It's a 5, right? And 34. Now, can you do something with 34? We don't know. Let's just prime factor it. 34, that's 2 and 17. They are both primes. So nothing is going to come out. So this is the answer right here. Okay? You can do the rest in the class. Okay, and this one is rationalization practice. So let's try this one. So you multiply by 1, but the denominator over denominator, right? So this is 2 over 2. So you get denominator is 2, the numerator is 2 root 7 root 2, which is 2 over 2 square root of 14. And 2 and 2 cancels, and square root of 14. Can we do something with 14? The factors are 2 and 7, they are both primes, so you can't do anything. Okay,